Hello, in this video we are going to find the maximum value of this function on an interval in the second derivative. And so remember, the first derivative is the slope and the second derivative is the slope of the slope, and the third derivative is the slope of the slope of the slope. And so in order to find the maximum on the second derivative, we need to find that point where the slope is equal to 0. And so then the slope of the slope of the slope go like that. The slope of the slope of the slope is equal to 0 at that point. And so to find our first derivative, we're going to use the chain function. We're going to treat this inside function as a u, so we got y primed is equal to, we're going to drop down that power using the power rule, 1/2 times 1 plus x cubed, subtract 1, we get negative 1/2 there, multiply all that by the derivative of the inside function using the power rule for x cubed, we get 3x squared, the derivative of a constant changes to 0, let's simplify that. We get 3x squared over 2 times 1 plus x cubed raised to the power of 1/2. Well, that was pretty easy. There's our first derivative. If we were stopping there, well, then we wouldn't really need to use technology. But as we'll see in the second example, using technology is much more efficient once again, because the second derivative and then the third derivative are exceedingly complex with the number of steps here. So in our second derivative, we've got a quotient, we've got 3x squared is f of x on the top, we've got 2 times the quantity, 1 plus x cubed raised to the power of 1/2 is g of x on the bottom. And so using the quotient rule, we've got 2 times 1 plus x cubed raised to the power of 1/2, all times the derivative of the top there. Subtract from that the numerator times the derivative of the denominator. And so again, we've got 1/2. We're dropping down that exponent. Remember, we still have our constant there. And those two are going to cancel out. And then we've got the original inside function. We're going to subtract 1 from the exponent using the power rule. Multiply all of that times the derivative of the inside of that second function. And then we've got g of x squared on the bottom. G of x squared is equal to 2 squared times the square root of 1 plus x cubed squared, which is 1 plus x cubed. Let's simplify that, y double primed. Then we've got 12x. We're going to split up this fraction into parts. We've got 12x on the top. Notice that we have 1 plus x cubed raised to the power of 1/2 here, 1 plus x cubed raised to the power of 1 here, so we're going to get 1 plus x cubed raised to the power of 1/2, or 1 minus 1/2 there on the bottom. And then we're going to subtract from that. We're going to distribute these 3x squared and 3x squared for 9x to the fourth. All of that is over. Well, this belongs on the bottom anyway because it has a negative exponent, so we're just going to raise that 1 to equal 1 plus x cubed raised to the power of 3/2, or 2/2 plus 1/2. And so now we can continue simplifying by finding a least common denominator. Well, the only difference between these two denominators is this one has a 1 plus x cubed, an additional 1 plus x cubed. So we're going to raise this first part of the numerator by that. We're going to multiply that first part of the numerator by that same part of the denominator on the second fraction there. So we're going to have one whole numerator, and then we've got a common denominator here, 1 plus x cubed raised to the power of 3/2. Distribute out that 12x, we get 12x times 1 is equal to 12x, 12x times x cubed is equal to 12x to the fourth. Subtract from that 9x to the fourth, we can combine like terms, and on the bottom here we're still going to have 1 plus x cubed raised to the power of 3/2. And so finally, we'll put our higher order first, so you get 3x to the fourth plus 12x all over 4 times 1 plus x cubed raised to the power of 3/2. There is our second derivative, and that wasn't so tricky. Not so many steps, but there were considerably more steps than the first derivative. Now, again, because we're looking for the point where the slope of the slope of the slope is equal to 0, or the maximum value of f double prime of x, the best way to do these problems is to use a calculator or a graphing algebra program like GeoGebra, but just for kicks, we'll do this third derivative by hand, and then for the second example, we'll do it all using technology here. And so, once again, we've got to use the quotient and chain rule. So to start off that quotient rule, we've got the bottom function, which is 4 times 1 plus x cubed raised to the power of 3 halves. And we're going to multiply that by the derivative of the top function using the power rule. 4 times 3 is 12. X, subtract 1 from the exponent there, add to that 12 because x to the power of 1 just drops the exponent, or sorry, drops the variable. Subtract from all that the top function, which is 3x to the 4th, plus 12x, and we're going to multiply that by the derivative of the bottom function. So we've got 3 halves times 4, which is 12 halves, or 6. We're going to multiply that by 1 plus x cubed. Remember, we're using the chain rule now. Subtract 1 from 3 halves, or subtract 2 halves from 1 half, we get 1 half. And then we're going to multiply all of that times the derivative of the inside of this function, which is still 3x squared. And then we have a denominator of 4 squared, which is 16, times 1 plus x cubed. We had it raised to the power of 3 halves. 3 halves squared is just 3. And so now we can begin the process of simplifying. First thing we want to do is distribute out this 4. So 4 times 12 is 48. 48x cubed plus 12 times 4 is 48. All of that quantity times 1 plus x cubed raised to the power of 3 halves. And then we're subtracting from that quantity. We've got 3x to the 4th times 6. 3 times 6 is 18. 18 times 3 is 54. X to the 4th times x squared is x to the 6th, plus 12x times 6. 12 times 6 is 72. 72 times 3 is 216 x cubed, and we're going to multiply that by 1 plus x cubed raised to the power of 1 half, and we'll keep our denominator the same at 16 times 1 plus x cubed raised to the power of 3. Continuing to simplify, we're going to split up this fraction into 2 parts again. And so we've got 1 plus x cubed to the 3 halves over here. We're just going to move this to the bottom, and we're going to get rid of some of these 48 and 16, have a common factor of 16, and so we're going to end up with we can go through an intermediary step here. 48x cubed plus 48 divided by 16 times 1 plus x cubed raised to the power of 3 halves. Subtract from that 54x to the 6th plus 216x cubed all over 16 times x cubed plus 1. We've got commutative property of addition there, so it doesn't really matter which way we phrase that. Raised to the power of 5 halves. Continue simplifying. So again, we can get rid of the 48 and 16 here. We've got a 3 and a 3. And then we can actually pull that 3 out, and we get 1 plus x cubed. That's very convenient because that is also on the bottom. And then we can use that later to further simplify. 1 plus x cubed raised to the power of 3 halves still. Subtract from that. 16 and 54 only share a common factor of 2. So we're going to factor out a 2 from each of these. We get 27x to the 6th plus 108 x cubed all over 8 times 1 plus x cubed raised to the power of 5 halves. Continuing the factor, we're going to put this down on the bottom. So we got 3 over 1 plus x cubed raised to the power of 3 halves minus 2 halves is equal to 1 half. And then we're going to subtract from that the same thing. 27x to the 6th plus 108x cubed all over 8 times 1 plus x cubed raised to the power of 5 halves. And continuing to factor and simplify. So let's put these into one fraction now. In order to find the common denominator here, well, we're going to have to multiply this 3 by an 8. 3 times 8 is 24, and then we're going to have to multiply that 24 by the difference of 1 plus x cubed is 1 half and 1 plus x cubed is 5 halves. Well, that's a difference of an exponent of 2, so 1 plus x cubed raised to the power of 2. And then subtracting from that 27x to the 6th, oops, 27x to the 6th plus 108 x cubed all over our common denominator of 8 times 1 plus x cubed raised to the power of 5 halves. And so we're in the home stretch now. We're going to distribute this this square here. We're going to FOIL. And so we get 24 times the quantity. 1 times 1 is 1. 1 times x cubed plus 1 times x cubed is 2x cubed. And then x cubed times x cubed is x to the 6th. And we're going to subtract from that still that 27x to the 6th plus 108 x cubed. And all of that is over 8 times 1 plus x cubed raised to the power of 5 halves. And finally, so we've got 24x to the 6th minus 27x to the 6th is equal to negative 3x to the 6th. Then we've got 48x cubed minus 108x cubed is equal to negative 60x cubed. And then we've got 24 as the lone constant up top, all over 8 times 1 plus x cubed raised to the power of 5 halves. All right, so that is our third derivative there. And that could take you a good hour if you make a couple mistakes, if you have to retrace your steps. That could easily take you an hour. So technology, people. And we're not done yet. We need to find that place where y triple primed is equal to 0. And so we've got negative 3x to the 6th minus 60 x cubed plus 24 all over 8 times 1 plus x cubed raised to the power of 5 halves. Well, this part gets easy. We can multiply by that because there's a 0 on this end. We just end up getting the top part there. We're going to divide by negative 3 and then divide 0 by negative 3. Doesn't matter. So we can get x to the 6th plus 20 x cubed minus 8 equals 0. And now we're going to use the quadratic equation. Remember that if x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, that means that we can say x cubed is equal to the cube root of all that. And so x cubed is equal, or sorry, x is equal to the cube root of all of this if we're looking in terms of x cubed. We don't have a quadratic here, we've got to the 6th, but it follows the same format because all of this is equal to x cubed times x squared plus 20x minus 8. Well, actually, no, not quite. At any rate, in order to find the solution to this problem, we can look at x cubed is equal to negative 20 plus or minus the square root of 400, which is b squared. 20 squared is 400, minus 4 times ac, which is 30, negative 32, sorry, plus, we're going to add 32 here. All of that over 2, and so then x is equal to the cube root of what we just had there, negative 20 plus or minus. We're going to end up with plus because minus doesn't make sense. Negative 20 plus the square root of 432, all divided by 2. And lo and behold, finally, we get x is equal to 0.732. All right, what does it all mean? What does it all mean? That's a whole lot of numbers. What does it all mean? Well, let's look at it graphically here. And so our original function was just as such. This here. Square root of 1 plus x cubed. Here's the slope. And you can see the slope is decreasing until it hits 0 here. Right? And then it's increasing and sort of levels off. So there's q primed, or the first derivative. Here's the second derivative. And you can see this is the slope of the slope, or the slope of the first derivative. And so we're at the origin here, you can see the first derivative is in fact leveled off. There's no slope of the first derivative at 0. And then here's q triple primed of x, finally. And again, what does it all mean? Well, what we were looking for is the point where the maximum value of f double primed on the interval is 0 to 2. And so we've graphed out, let's look at just f double primed here. And in order to find the maximum, I've mapped it out already. Maximum, I just did like this. Maximum of the function is q double prime. The start value is 0, the end value is 2. And so we get 0.73, which is exactly what we solved for, but we didn't even get the x value there. We only got the y value. Or sorry, we didn't even get the y value. We only got the x value because we didn't plug it back into the equation. But needless to say, technology is the way to go here, folks. So let's look at a second problem. Our second problem is this one here. So we're looking for the value of f double primed of x where it's the maximum between the interval of 1/2 to 3. And so instead of spending 15, 20 minutes an hour going through all of the ludicrous calculations, writing it all out by hand, let's instead just go directly to the technology. And so here we've got f of x. And let's just get rid of the brain rot that we just went through with that last problem. Here's f of x. And in order to find the derivative of f of x, we just have to type in derivative and f of x. There's the derivative of f of x. And then let's type in derivative again. Derivative of f of x, except this time let's say 2, the second derivative of f of x. And so let's then type in the third derivative of f of x, or actually we could just say the maximum, where we don't even need to find the third derivative just yet. So we're looking for the maximum of this function on the interval from 1/2 to 3. from 1/2 to 3. So let's say the max. The function is f double primed of x. The start value is 1/2. And the end value is 3. Oh, and isn't it beautiful? Isn't it wonderful how quick and easy that is? And so there's our maximum value. And if we're just suspicious of our technology, still, let's try the derivative of f of x, except we're going to say the third derivative this time. And what do we see here? And if we're still really suspicious, let's look at a point, an intersection of f triple primed of x and the x-axis, and we get, oh, right there at 1. So the maximum value of this function, of the second derivative of this function, is at x equals 1, and then there y equals 1/2. And so later on in calculus, we'll look at inflection points and these different things. But I think a main idea of this lesson is that technology is a wonderful, wonderful tool, and we shouldn't waste it, neither in the classroom nor in our homework, and certainly not at work in the real world, because it took us about 20 minutes to an hour to do something that should have taken seconds right there. Okay? Thank you.